again, what I'm saying here is that when you do integration, you're doing an antiderivative. And if I ask you guys, what are the most important rules we learned about derivatives? I would argue there are two. So there are two rules for differentiation that I think are very important. What would you list if you had to list one of the rules of differentiation? Give me one. Okay, we mentioned the chain rule. How about another one? Quotient rule, and what else? Product rule. I'm going to say product rule because honestly, the quotient rule, while it is kind of cute, it's just the product rule. A quotient is the reciprocal of a product, and if you apply the product rule to any fraction, you'll basically get the quotient rule. Now, if you say that these are the two most important rules for differentiation, then what I would say is we're going to have some corresponding techniques of integration because it's going backwards. So today, when we start talking about the chain rule, we're going to start talking about what I call U substitution. U substitution. Why the letter U? It's just very standard. People are going to use the letter U to represent a function of x. Probably because a lot of other letters are already taken. Y is a function of x, right? Z, that's for complex numbers. We'll save that later. Or you'll use it in Calc 3, I guess. So we're losing the ink. All right, here we go. The product rule. Let me just, while I'm at it, tell you, you could save this for whenever you're going to take Calc 2, although I saw a couple people signed up this summer. Integration by parts is the technique you use that corresponds to the product rule. And this will be covered in Calc 2. I think it's Chapter 8, Section 2. Okay? So we're not going to touch that in this course. But we're going to do U substitution today. So I'll show you how this works. What's that? What do you mean? No. Well, will you use both of these techniques at the same problem? Absolutely, if that's what you mean. No. What I guess I was trying to understand your question. These are two rules we know how to do for what I call going forward, taking the derivative. What I'm going to show you now is these techniques which are basically doing that going backwards. Well, at least I'll show you one of them today. One of them you got to wait for Calc 2. Okay? So let's see. I'm going to give you an example. Suppose I said we want to integrate this guy. 4x minus 5 squared times 4. I want to integrate that. I guess the question is, can you integrate it? Sure. If I want to what? Oh, I've given you problems you can't solve, haven't I? I want to find the antiderivative. And notice for now, I'm going to make it an indefinite integral. We've been working very hard on area, but I'm going to wait until you work more on that. For now, let's just work on how do you find the antiderivative. Once I find it, I can substitute in f of b minus f of x. So, how do you do it? Well, one thing you could do, right, would be to multiply 4x minus 5 times 4x minus 5. And then what would you do next? Probably multiply by 4, and you get some big polynomial. And then you could go, you basically have to do 3 little antiderivatives for the 3 terms you'd be left with. Does that make sense? So we know we can do it that way. Of course, if I change that 2 to a higher number, you're going to be less likely to want to try to do that. So here's the question. Wouldn't it be really cool if instead I could just do something like this. 4x minus 5 to the third power. Wouldn't it be cool if that were the answer? Is it the answer? Plus c. Why plus c? Because it's indefinite. Right? Why do you say no? Well, don't guess. You don't have to guess. You could always check. How do you check? Go ahead and do it. Put something in front of it? What should I put in front of it? If I put a 1/3 in front, wouldn't that be cool if that were the answer? So let's check, right? How do I check? So if I call this thing a of x for answer, all right, then how do I check? Okay, a prime of x is, bing, bring down the 3, right? That's going to do what? That's going to cancel out with the 1/3, which is a good thing. Bing, 4x minus 5 squared, and then what? Bong, the 4. Ryan asked at the beginning of this, hey, what's with the 4? Was it a good thing the 4 was there? Yeah. It was a good thing the 4 was there. Right. Jonathan's getting at what I'm getting at here. See, if I had given you this problem, here's what Jonathan's saying. Suppose I just gave you that problem. 4x minus 5 squared dx. And you want to use the same shortcut. The problem is you don't have what? You don't have the 4. So if you were clever, you would think of doing this. Putting the 4 in there. Now, are you allowed to just multiply by whatever you want? No. But you are allowed to multiply by 4 if you also multiply by 1/4. So what I would do is multiply by 1/4 on the outside. We'll see this at work in a minute. And then I would work out this answer, but I would have a 1/4 multiplied by what I did for the last problem. Let's get rid of that for now. Let me show you the slow motion or the substitution way to do the same problem. Use substitution. Okay. So, why don't I go ahead and take the problem we were just talking about. 4x minus 5 squared dx. Okay? So what I'm going to do is I'm going to change variables. I'm going to say let u equal, well, what I'm going to do is let it equal what's in parentheses here. 4x minus 5. Okay? Now I want to skip a few spaces. And I'm going to point out that my integral now becomes the integral, the antiderivative of u squared. Do you guys see that? Okay. But if my variable is u, I can't put the differential dx. That won't make sense. But I also can't just put du. Not yet. I need to compute the differential du. And I do that here. du is equal to, do you know what it equals? 4 dx. Now, let me slow down there. A lot of people like to write an intermediate step. The book won't do this. Some people, when they're first learning, will write du dx equals 4. See, if u is 4x minus 5, what's the derivative of u with respect to x? It's 4. Are you with me? And then what do you do with that dx? You separate the variable. We've done that before. Now, what does that mean? Well, it means I don't have du yet, do I? I'm missing the 4 that I need. So I guess what I do is I say, okay, I'm going to multiply by 4, but if I multiply by 4, I also have to multiply by what? 1/4. You see that? Now I have 4 dx, which is the same as du. So what I get is 1/4 the integral of u squared du. Does this make sense? Let's finish the problem. What's the antiderivative of u squared du? Well, u squared is going to become what? U cubed, but what do I have to put out front? 1/3. And I also have a 1/4 that was out front. So I'll put a plus c. And now to finish the problem, I'll write that this is 1/12, but I don't want my u's, so I want to go back and put in the original function. So what am I going to put? 4x minus 5 was what u was, cubed plus c. So this is the antiderivative of 4x minus 5 squared dx. Here I was lucky, I already had the 4. Here I didn't, I had to insert a 4, so I put a 1/4 out front. It's a little bit tricky. I'm sorry, what? What happened to du? Here, let's do the one on the right. So, wow. You know, when I used to take derivatives, how would I write a square root? Right. What I'm going to suggest we do is this. Let's do a substitution. Let's write u equal to, any guesses what I'm going to let it equal? X cubed plus 9 is what I'm going to try. And I'll be honest with you, part of the game in section 5 is, what do you let u equal? And what you do is, you try it. If it doesn't work, you try something else, okay? That's part of the game. You learn by experience. Anytime that I compute u, you know what my next step is? Compute what? du. So what does du equal? That's right. Du dx is 3x squared. So I could just say that du is 3x squared dx. But you guys are so used to the chain rule, you're used to that. Bong. Does that make sense? Okay. So now what you do is you kind of look at your integral and you say, do I have the du that I want? Do I have a 3x squared dx sitting in there? I have an x squared and I have a dx. What's the thing that's missing? A 3. It'd be really nice if I could get a 3 in there, right? So what am I going to do? I'm going to multiply by 1/3, and then I'll have my 3. So what I'll have is I'll have, well, the square root of x cubed plus 9, and then I'll have my 3, and then I'll have my x squared dx that I already have. Does that make sense to people? Because what I want to get is I want to get, when I substitute, I want to get my du. And then what would this be? Sure, it's the square root of u. U to the 1/2. What's that? Half of u. U to the 1/2. Make sense? So what do? Now we can do the antiderivative because I have it. This one is one you know how to do. This one, forget. But this one I can do. So what do? Let's see. U to the 1/2 is going to become u to the what? Well, let's do the power first. What's the power going to become? 3/2, but then what do I have to put out in front? 2/3, so that when I take the derivative, I get back that. And I also have something else out front. What do I have? The 1/3 that came from the substitution. And then I need to put a plus c. Don't forget that. So my final answer to this one would be 2/9. And then I guess I would probably write x cubed plus 9 to the 3/2 power. That's what u was. Plus c. Good problem. So let's see. So this is a problem we did before, except that before we didn't have it as a definite integral. We had it as an indefinite integral. Now I want to show you how to handle this. I have to be really careful here when it's a definite integral. Let me show you something. If I write a 0 and a 3 here, I'm in big trouble. Because what would the next step be? The next step would be, well, we write u to the 3/2 power, right? What goes out front is 2/3, right? And what would you do with this thing? Oh, you don't write a plus c. Remember? What do you do instead? You put this bracket, and do you remember what goes here? Okay? But I'm telling you I'm in trouble, because what students sometimes do, and I can remember myself doing, is plug in the 3 and the 0 into u. See, these aren't u values, are they? What are they? So you might want to be really careful with labels, you know. X equals 0 to x equals 3. Does that make sense? And now, let's see what I have. 2/9 of, and u is this x cubed plus 9. So let's write x cubed plus 9 to the 3/2 power. And now we will plug in a 0 and a 3. Does this make sense? So let's see what I get. I get 2/9 of, now when I plug in 3, what's 3 cubed? 27 plus 9, 36. That's actually a nice answer. I get 36 to the 3/2 power. That's something I can compute. Minus 2/9 of what to the 3/2 power? Careful. 0 plus 9 is 9. So 9 to the 3/2 power is also something I can compute. But what does this say to do? This says take square roots. So this is 2/9 of 6 cubed minus 2/9 of, well, 3 cubed. All right? So this is 2/9 of, well, 6 cubed I think is 216. 3 cubed is 27, so I get 2/9 of, help me out here, 183, I think, or 193, 183, okay, so it's 2/9 of 183, whatever that is. I'm going to stop, okay, so that's what it equals. There's another way to proceed, okay, and I want to show you that. So the alternative way to do this, if you write out 1/3 to 189, yeah, 189, 2/9 of 189, whatever that is. Okay, thanks. The alternative way to proceed is we had 1/3 integral u to the 1/2 du. But this is really kind of cool you can actually change from the world of x's to the world of u's. Let me show you how to do that. Here, I'll make a little room in the side. Yeah, we're going to change those x limits into u values. Because what I know, see it says u is x cubed plus 9. Well, that means u is a function of x. U of x is x cubed plus 9. So just plug in. What is u of 3? 3 cubed plus 9 is 36. That's right. And we already worked these things out, didn't we? U of 0 is 9. And so what you end up doing is you integrate from 9 to 36. And now you're golden, right? What do you get? You get 2/9 u to the 3/2, and you just put a 9 here and a 36 here. And can you see that you're actually going to get exactly the same thing? Okay? This is another approach. For some reason, when I was a student in Calc 1 and 2, I always kept the x's. I was just more comfortable that way, and then I would plug in at the end. But I see no reason now why not to do that. So, you kind of pick what you're comfortable with, I guess. Here we go. Well, I'll show you the right u. U equals the stuff in parentheses, 30 minus x squared. And then du is what? Negative 2x dx. Hey, why do I have dx's both places? Did I really have that on the slide? Oh, that's wrong. Okay. Now, actually, I'll tell you one lucky coincidence. Sometimes the problem will be written this way, with a dx in the numerator of the fraction. Sometimes instead they'll put it out here. It's the same problem, okay? But no, it shouldn't have it both places. So sorry about that. Okay. So do we have our du? Not quite, right? We need to get a negative 2 up there, and then we'll have du. And so if I multiply by negative 2, I also need to multiply by negative 1/2, right? So to compensate. Okay? So the original problem was this. So I get negative 1/2 integral. Now I have my du. The x dx plus the negative 2 I multiply by is the du. And what do I get? This is u to what power? Yes, in the denominator. So to speed things up, I'll write it as u to the negative 2 du. Is that okay? Fast. That's because I'm almost out of time. Negative 1/2. Oh, and what did I not do? I didn't put in these values we had. So let's see. If I put in 5, so u of 5 is 30 minus 25, which is, oh, lucky. And u of 3 is 30 minus 9, which is, now that's weird, 21. Can you really do that? Isn't that weird? So what if I did this for my next step? Made this a plus, and made this the integral from 5 to 21. I don't have to do that, but does it make sense to you? Because instead of f of b minus f of a, I'm doing f of a minus f of b, so that's the negative. Does that make sense, people? I don't know. We're trying, guys. U to the negative 1 power is what I get up when I take the antiderivative. But then I have to put a negative out front. Now I'm back to negative. And here's 5, and here's 21. So I get negative 1/2, and these are u values. so I can plug them right in, of, by the way, u to the negative 1 means 1 over u, evaluated from 5 to 21. So this is negative 1/2 of 1 over 21 minus 1/5, whatever that equals. That's a positive answer, which is good, and I'm done.